Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Catalytic hydrogenation of alkenes adds H2 across the double bond to give alkanes. Isopentane, to methylbutane, has the structure CH3CH, CH3, CH2CH3. We need to find all alkene structural isomers with molecular formula C5H10 that upon hydrogenation yield isopentane to methylbutane specifically. Moving on to the next step. Draw the carbon skeleton of isopentane to methylbutane CH3CH, CH3, CH2, CH3. It has 5 carbons with a methyl branch at C2. Moving on to the next step. To get isopentane by hydrogenation, the alkene must have the same carbon skeleton as isopentane to methylbutane, i.e., a branched 5-carbon chain with the same connectivity, and the double bond can be placed at any position within that skeleton. And for the final step, enumerate all alkenes with the 2-methylbutane skeleton, C5H10, that hydrogenate to 2-methylbutane. 1,2-methyl, 1-butene, CH2 is equal to C, CH3, CH2, CH3. 2,2-methyl, 2-butene, CH3C, CH3 is equal to CH, CH3. 3,3-methyl, 1-butene, CH2 is equal to CH, CH3, CH3. Check if any other alkenes, example, straight-chain pentenes, give isopentane. Straight-chain pentenes, 1-pentene, 2-pentene, would give N-pentane, not isopentane. So they are excluded. There are exactly 3 alkenes, 2-methyl, 1-butene, 2-methyl, 2-butene, and 3-methyl, 1-butene that on catalytic hydrogenation give isopentane. Why other options fail? A. 2 misses one of the 3 valid alkenes. C. 4 and D. 5 overcount. No additional alkenes with the 2-methylbutane skeleton exist. Therefore, the correct answer is B. Therefore, the correct answer is option B.